Alright, what is up, my folks? So it seems like today we're going to go ahead and talk about how in which the company that I work for right now, what it allows us to do in a furnace and AC tune-up. Now, different companies might do it the different ways, but this is the way that the company in which I work for allows us to do in the time that they give us. So, first off, what is an AC tune-up? So it means basically that you go ahead and check the system, do any maintenance such as washing the outdoor condenser, adding refrigerant and looking for a refrigerant leak, or changing out capacitors and contactors, blower motor, amperage checking, check out the filter, all that good stuff that might affect the refrigeration system. Now right here you see the dog. They did let me know that he was kind of nervous, but he definitely was very, very nervous to see me there. Kind of confused, but there he goes. Alright, so before I do anything, I like to go ahead and inspect the unit as a whole. So as you saw, I did a quick walk around and then I saw the dog, got distracted, and then I'm back into it. So as you can see, I go ahead and take a look at the unit, and here I take out my stubby. Now stubbies are great for ACs because, as you know, they put them right against the wall, and then sometimes that plate is not reachable with a drill or a regular 11-in-1 Klein. This stubby has gotten me out of many issues. Now, something in which I do have to mention is that obviously some people might do it differently even if they have the same amount of time. But this is what within the company that I work for, what they have taught us to do during an AC tune-up. Now before all of this, I did check that filter. So the filter is clean, blower motor amperage is all good and set. So I went ahead and checked that off the list. So I'm starting off with this video on the condenser. As you can see, I have there my high side probe. Then I like to use a low loss fitting for that high side because I don't want to get burned by that high pressure blowback. Some people already are experienced and can, do it without that. But me, I like to play a little safe. You can never be safe in this industry because there's always going to be danger. Now, that's a separate video in which I plan to do is on safety because it's a really big issue in the resi industry. It seems like once you move to residential, safety just flies out the window. So as you can see here, went ahead and opened up the Measure Quick app, zeroed out my probes, and now I'm going to go ahead and take a photo of the unit. Now we installed this unit, however, they didn't have any photos provided from when they installed it. So I just go ahead and make the office life a little bit easier because then they're for sure going to yell at me for not getting that info. Now go ahead, pull out the disconnect, check for voltage. Now sometimes I know it's a bad practice, but I like to push down on the contactor after pulling out the disconnect. That just lets me know if there's power. Now in some units, such as the Carrier Infinity units, those you won't be able to push down that contactor because those are already pulled in. Some of the Lennox units, the communicating ACs in general, those are the ones that are going to have the contactor pulled in. The board is the one that controls whether it turns on or not. And as you can see here, I'm going to go ahead and check the capacitor. Now, sometimes I like to use my drill. Sometimes I like to get creative and use different tools. In this case, I felt like getting creative. As you can see, I'm using the stubby with an extension. Now, the extension is a 1/4. We'll unscrew a 1/4 screw. And as you can see there, I go ahead and de-energize that capacitor because we don't want to get shocked today. Now, I've personally never gotten shocked, but I've heard many people have. So there's a lot of mixed opinions about that. Now obviously before you disconnect everything, go ahead and take a look at where all the wires are located, because last thing you want to do is go through the schematics and see where everything goes. Now it's not that difficult to do, but it just takes time out of your day. Now here you see that I'm checking the microfarads on that capacitor. Now the way that you check microfarads in a capacitor is from common to Herm and from common to fan. And then depending on the ratings of the capacitor, you can measure plus or minus 5. It will say right there in the nameplate, as you can see right there. I'll move. I do believe I have the common as the black lead. Yeah, and I'm trying to get a good contact there, because sometimes you gotta move that rust around it, or you gotta leave it on there for quite a while for it to read it. So you can't see very well here, but yeah, I am measuring from common to Herm and from common to fan. Everything checks out. I go ahead and put everything back. Now, like I said, make sure you either take a picture or you write down where each wire will land on that capacitor. Last thing you want to do is put your Herm side on the common and your common on the fan. Now I like to put that disconnect back in. Make sure that contactor will turn everything on. Basically just checking that I wired up that capacitor back up right. And as you can see, I just go ahead, take out that disconnect again. Check again that contactor. Now, like I did mention, I know some people are going to probably hate on this, but I like to just go ahead and push that contactor in for safety. See, I'm still getting creative. Now this doesn't work very well because that extension bit isn't magnetic at the end. So as you can see, I'm trying to hold everything together without it falling. So there you go. I got everything back in. Okay, and now I'm gonna go ahead and hook up my probes. As you can see, this 45-degree low loss fitting really does help it in that tight little area. I do have also 90s and also just straight fittings if I do need them, but the majority of the time I'm using that 45-degree angle, because 45 plus 45 you get 90 degrees. So I mean, it just helps me personally, whatever helps you best in the field. Now for the low side, that one is, since it is at a lower pressure and it's not pushing refrigerant, more like it's pulling, it doesn't have that much of a blowback, so I don't put a low loss fitting on that one. Now I'd just like to go ahead and check one more time that contactor is still off, even though I'm not going to do anything. And then just go ahead and push that contactor in without turning anything on. Because as you can see, I'm just going to go ahead and get a rough idea of where the pressures are at before I fully turn on that AC. Alright, so as you can see here, pressures are checked and verified. Now, I like to use the Measure Quick app because it has a lot of features. Now, I know recently they had an update where there's a lot of things in which are paid. Well, they have to be paid for. But overall, that app is still great. I just really don't like that paid version. I would highly recommend getting that app. because as you can see, I can check the pressures on my probes. Even if you don't have probes and just have those standard analog gauges, you can just input all the numbers into Measure Quick and it automatically tells you superheat, subcool, dry bulb, wet bulb. Obviously you do have to put in the temperature that the indoor air is coming out and what it's pulling back in. But it's really great. It's a really great app that I enjoy using. And as you can see, I'm also taking the temperature of the pipe. I have my clamp on the liquid line, and then I'm gonna go ahead and put it on the suction line in a second. And I do have the wireless ones, however they did run out of battery. That's another great thing about having a backup, is that even though your primary might go out, you still have that as a backup. I remember one time I left one of my probes at a customer's house, and obviously I had about 3 or 4 more calls left, and I had my analog gauges to input everything into Measure Quick, and that worked out perfectly for me. So go ahead and get yourself a second pair of everything, because you will lose everything, as some of you might have already know. Now right here, I'm just making sure that the info is inputted into our system. Like I did mention, I like to make the office job a little bit easier, because they already handle calls, they handle permits, they handle parts, part updates, they handle shipping, receiving, and all that. That's basically it in which what I do for an AC furnace tune-up. Now, like I did mention, there's many other companies that do it differently, but this is what the company in which I work for allows, and what they want us to do. Obviously, we will change a capacitor if it's needed, change out a contactor, all that stuff. But for this type of situation, it was about a 2-year old condenser, I believe, if I remember correctly. So it didn't need too much of maintenance. It just needed everything checked, make sure that there was no leak, make sure that the contacts are good, no wires are loose, blower motor amperage is all set, and the filter to be changed. It wasn't too dirty, but still, we just go ahead and change that out. So apart from that, everything else went smoothly, and this is something in which a beginner can do. Obviously, there are more advanced maintenance techniques. Now, if you work in a commercial setting, yes, you will have a lot more time to do different things and to do them all at the same visit. Now with us, if we have to clean a condenser, it's a separate visit. If we have to come back because we don't have certain parts, then yes, it's a separate visit. So go ahead and let me know if you guys like these type of videos, that way so I can make more. If not, then this will be the last one, but just go ahead and let me know, because I do want to know if that these videos are good or if they're not. Well, thank you for watching, and we'll see you in the next one.